Okay, so for this purple paper, what we need to go over is what are the possible solutions for a system of equations, okay? So we already know a system of equations is two or more equations, and bottom line, you're trying to find out if they intersect. The point of intersection is the solution. So let's start with the first one. Notice how the first equation is already in slope-intercept form. That's perfect because we can graph it right away. Slope will be 1, y-intercept will be 3. So I'm going to put a dot at 3. And then do my slope, rise 1 over 1. And I'm going to keep doing that. And I'm also going to do the other side. So I'm going to go down and left. Down 1, left 1. And you do that all the way. And there's your first line. The second line is not in y equals. And the only reason why it's not in y equals is because of this minus 6 and because of this 2 multiplying my y. So the first thing you want to do is move over the 6. You want y alone, so move over that one. You're going to be left with 2y equals 2x plus 6, and divide everybody by 2. So y equals 2 divided by 2 is just 1x. 6 divided by 2 is 3. So now I got my other equation in y equals, so I can graph it as well. So the y-intercept is 3. There it is. And then my slope is 1 over 1. So, what do you notice? You notice that they're exactly the same line. We didn't know that at the beginning because they look differently, but they ended up being the same thing. So when I ask you what the solution is for this system of equations, it's like, well, they're crossing everywhere. They're the exact same line. So for this one, we're going to put infinite solutions because they are the same line. They just look different, but when we graphed them, we realized, hey, same line, so they're going to cross everywhere. Infinite solutions. Now let's go over here. The first one, again, is already in slope-intercept form, so start by graphing the y-intercept. And then this negative, remember, we can just give it to the top number. It doesn't belong to both, just one. So I'm going to drop 2 down, 3 to the right, 2 down, 3 to the right, 2 down, 3 to the right. I can also do the opposite of down and right. I can go up 2, left 3. And there's your first one. Now the second equation, as you can see, it's written in standard form. So we want to solve for y. So we're going to move the number with the x. We're going to have 3y equals 9 minus 2x. We're going to divide by 3. And we have y equals 9 divided by 3 is 3. I cannot do much to this one, so I'm just going to write negative 2/3 x. Your y-intercept is your 3. There it is. Your slope is down 2, right 3. Down 2, right 3. Down 2, right 3. Down 2, right 3. Or I can go up 2, left 3. And you can clearly see what's happening. What kind of lines are these? Well, these are parallel lines, and I should have known because parallel lines have the same slope but different y-intercept. So I should have known from the beginning these were going to be parallel. So are they going to intersect? No. So what's the solution? No solution. And this only happens, of course, with the parallel lines. Okay, so possible outcomes: infinite solutions, no solutions, and let's check out this last one. So let's solve the top one for y. So I'm going to have to move the 2x. I'm left with negative y equals 4 minus 2x. And then I have to divide everybody by negative 1. So y equals 4 divided by negative 1 is negative 4. Negative 2 divided by negative 1 is positive 2. So there's that first one. So let's go ahead and graph it. Y-intercept first. 1, 2, 3, negative 4. And then your slope is 2 over 1. Up 2 over 1. You can also do left 2, or I'm sorry, down 2, left 1. And then there's your line. Sorry about that. Okay. Then you graph the second one. Start at the y-intercept. Slope is 1 over 3. So 1, 1, 2, 3. 1, 1, 2, 3. I can also go down and left 3. And notice I'm not going to have to plot that many because I see my point of intersection. How many times does it cross? It crossed perfectly once, right here. At what point? 1, 2, 3, 1, 2. It crosses at 3, 2. So this one we say has one solution. And those are the only outcomes you can have in a system of equations. You either have one solution, if they cross once, of course, if they're intersecting lines, no solutions if they're parallel, and infinite solutions if they ended up being coinciding lines, the same thing. Now, glue this to your spiral as well. This is paper number 2.